Welcome. This lesson is on Coulomb's law for two-point charges in free space, which is a subtopic of electric forces due to point charges in Unit 18 electric fields. By the end of this lesson, you should be able to recall and use Coulomb's law, F equal to Q1 times Q2 over 4 pi epsilon 0 times R square for the force between two-point charges in free space. Imagine two-point charges, Q1 and Q2. The charges can be two positive charges, two negative charges, or two opposite charges, separated by a distance r. The force each charge exerts on the other is F. Physicist Coulomb found experimentally that the magnitude of the electric force between two-point charges is directly proportional to the product of the charges, and inversely proportional to the square of their separation. So, the magnitude of the force F between the two-point charges, Q1 and Q2, separated by distance r, in a vacuum, can be written as F equal to K times Q1 times Q2, divided by R square. The constant K is the constant of proportionality, and is known as Coulomb's constant. The value of K is 9 times 10 to the power of 9 Newton meter square per Coulomb square. This constant K is usually given in the form K equal to 1 over 4 pi epsilon 0. The new constant epsilon 0 is the permittivity of free space or vacuum. Epsilon 0 takes a value of 8.9 times 10 to the power of negative 12 Coulomb square per Newton per meter square. The above equation applies only to charges that are in a vacuum. If the charges are immersed in a different medium such as water, then the value of permittivity is different. For example, the permittivity of water is around 7.8 times 10 to the power of negative 10 Coulomb square per Newton per meter square. The directions of the electric forces can easily be worked out by using the fact that like charges repel and unlike charges attract. Let's try some examples. Please pause the video to try the question. In this question, both the alpha particle and the proton carry a positive charge. So, the electric force is repulsive. We can use the equation of Coulomb's law to calculate the magnitude of the electric force. The alpha particle is the nucleus of helium-4, contains two protons, and thus, it has the amount of charge, 2 times 1.6 times 10 to the power of negative 19 Coulomb. The charge of a proton is 1.6 times 10 to the power of negative 19 Coulomb. It's given in the question. The separation between alpha particle and proton is 20 micrometer, which is equal to 20 times 10 to the power of negative 6 meters. The value of constant K is 9 times 10 to the power of 9 Newton meter square per Coulomb square. Substitute the values into the equation to calculate the value of the electric force, which is 1.15 times 10 to the power of negative 18 Newton. Let's try the second example. Please pause the video to try the question. From Coulomb's law, the magnitude of the electric force between two-point charges is inversely proportional to the square of their separation. We are given in the question, when their separation, x is capital R, the electric force is Fc. From the proportion, when their separation, x becomes 1.5 r, the force will decrease by a factor of 1.5 square, which is 0.44 Fc. When their separation is doubled, the force will decrease by a factor of 2 square, which is 0.25 Fc. When their separation becomes 2.5 r, the force will decrease by a factor of 2.5 square, which is 0.16 Fc. When their separation becomes 3 r, the force will decrease by a factor of 3 square, which is 0.11 Fc. When their separation becomes 4 r, the force will decrease by a factor of 4 square, which is 0.06 Fc. Then, we draw the curve passing through all the points to get the graph. The graph has the shape of the function y equal to 1 over x square. Let's try another example. Please pause the video to try the question. In this question, we can use the equation of Coulomb's law to calculate the magnitude of the electric force. The charge of a proton is 1.6 times 10 to the power of negative 19 Coulomb. It's given in the question. The separation between the two protons is x. The value of constant K is 9 times 10 to the power of 9 Newton meter square per Coulomb square. Substitute the values into the equation to get the expression for the electric force. Next, we can apply the equation for Newton's law of gravitation to calculate the magnitude of the gravitational force. The mass of a proton is 1.67 times 10 to the power of negative 27 kilograms. The separation between the two protons is x. The value of gravitational constant g is 6.67 times 10 to the power of negative 11 meter cubed per kg per second square. Substitute the values into the equation to get the expression for the gravitational force. Then, we can get the ratio of the electric force between the two protons to the gravitational force between the two protons. Simplify and calculate to get the ratio, which is 1.2 times 10 to the power of 36. Obviously, the electric force is much greater than the gravitational force. We have come to the end of this lesson.